Ladies and gentlemen, may I have your attention, please? The show starts in 3, 2, 1.
Be on deck, keep it in check. When you need that, I'ma let you have it. Beats in the drum like dum diddy day. I like the dirty rhythm you play. I wanna hear you calling my name like, hey mama, mama, hey mama, mama. Banging the drum like dum diddy day. I know you want it in the worst way. I wanna hear you calling my name like, hey mama, mama, hey mama, mama.
Hi, Assalamualaikum everyone. Today, our group want to explain about continuous random variable. A continuous random variable is one which takes an infinite number of possible value. Continuous random variable are usually measurement. That's the probability in continuous random variable it equal a particular value at is 0. That is, probability that big X is equal to little x is 0. This is because we can always measure more accurately for continuous random variable than any number that we specify. Continuous random variable have two types, with a probability density function or PDF and cumulative distribution function or CDF. Specifically, to answer this question, let's firstly do examine overarching factor of PDF. Firstly, f of x is greater than 0 for all x. So, you can never have a PDF ever go below 0. Essentially, this is because it will suggest an outcome or interval has a negative probability, and we all know the lowest probability that you can have is 0. Secondly, the area under the word PDF is 1. You will see more about why this is in a moment, but that word the sweeping generalization stop a PDF is just a positive function whose area underneath is 1. So, the conclusion, the area under the PDF in a specific region is the probability that the random variable x is between that value. The cumulative distribution function or CDF for a continuous random variable x is defined f of x equal probability that big x is equal to little x is 0 equal integral between x to a f to t dt. From cumulative distribution function, median, first quartile and third quartile can be determined. The formula to get median with is f of m equal to 1 over 2, f of first quartile equal to 1 over 4 and f of third quartile equal to 3 over 4.
Next, we move to expected value or also known as mean and variance. The expected value or mean and variance of a continuous random variable can be determined with the help of the probability density function fx. The expected value or mean is one of the important and most commonly used measure of central tendency. There are several types of means in mathematics. The definition of mean is the average or a calculated central value of a set of numbers, and it is used to measure the central tendency of the data. Central tendency is the statistical measure that recognize the entire set of data or distribution through a single value. It also provides an exact description of the whole data. In statistics, the mean can also be defined as the sum of all observations to the total number of observations, and the symbol for mean is represented as X bar. However, the mean of a continuous random variable can be defined as the weighted average value of the random variable X. It is also known as the expectation of the continuous random variable. The formula of expected value or mean for continuous random variable is equal to integral negative infinity to positive infinity of x times fx. Then ES for continuous random variable has the same properties for ES of discrete random variable. Next is the variance. Variance is a statistical measurement that is used to determine the spread of numbers in a data set with respect to the average value or the mean. The standard deviation squared will give us the variance. Using variance, we can evaluate how stretched or squeezed a distribution is. But the variance of a continuous random variable can help determine as the expectation of the squared differences from the mean. It helps to determine the dispersion in the distribution of the continuous random variable with respect to the mean. The formula for variance in the continuous random variable is the expected value of the random variable x square minus to the mean or expected values square. Lastly, variance of a continuous random variable also does share the same properties variance of discrete random variable.
So next, I will continue the presentation, which my part I will explain to you about the situation that related to continuous random variables. Before I give you the example question which related to continuous random variable, I want to explain to you about mean and variance in continuous random variable. As we know, the mean is the same as expected value of the random variable, and you may remember that for a discrete random variable, that's equal to the sum of the probabilities time to the possible values of the random variable. Now, for the continuous random variable, we place the sum with an integral sign and we replace the probabilities with probability density function. So, the mean of a continuous random variable is the integral of x over all possible values of x. Okay, now for the variance. The variance of a random variable, which can be written sigma squared or var x. You may remember, variance is equal to the expected value of x squared and take away the square of the mean, and for discrete random variable, that's equal to the sum of the probabilities value of x. Take away the mean squared, and again for continuous random variable, you replace the sum with an integral sign and we replace the probabilities with the probability density function. So, the variance of a continuous random variable is the integral of x squared f of x evaluated over all possible values of x minus the square of the means. And these are two things you need to know to find mean and variance for continuous random variable. As you can see on the slide, which the question asks about the continuous random variable, here is the situation where it's stated that in each turn of a game, a coin is pushed and slides across a table. It given the distance x meters which traveled by the coin has probability density function given by function x equal to kx squared in bracket 2 minus x, where x is in between start from less than or equal to 0 and also less than or equal to 2. One more function given is 0 and otherwise. And it also stated that k is a constant. So from this situation, the question asks to first show that k is equal to 3 over 4, and the next question is find the mean and variance distance traveled by the coin in one turn. Okay, now I will pass to the next presenter, which they will explain about how to solve all the questions given.
We will discuss the answer from the question, which is show that k equals to 3 over 4 and the mean distance traveled by the coin in one turn. For the first question, because fx is a probability density function, so when we integrate fx dx from negative infinity to infinity, the answer should be 1. Next, when we integrate everywhere besides 0 to 2, it should be 0, which means integrating kx squared times 2 minus x dx from 0 to 2 will equal to 1. And then, we need to expand it by multiplying kx squared with 2 minus x, and we will get integrating 2kx squared minus kx cubed dx equals to 1. Now, we can go ahead and integrate using the power rule, and the answer that we will get after the integration without applying the value of x is 2kx cubed over 3 minus kx to the power of 4 over 4 equals to 1. Next, we will apply the value of x, which is 0 and 2, and we will get 4k over 3 minus 0 equals to 1. And then we need to move 4 over 3 to the other side, and we will get the value of k, which is 3 over 4, and the value of k has been proved. For the second question, which is to find the mean distance traveled by the coin in one turn, the formula for mean is the expected value equals to the integral from negative infinity to infinity of x multiplied by fx dx. Next, we will get an integral from 0 to 2 of x times in the bracket kx squared multiplied by 2 minus x dx. Then we need to exchange the value of k with the value that we get from the first question, which is 3 over 4, and we will get an integral from 0 to 2 of x multiplied in the bracket of 3x squared over 4 multiplied by 2 minus x dx. Next, we need to expand by multiplying x squared with 2 minus x, and we will get x times in the bracket 2x squared minus x cubed, and we can put out 3 over 4 because it is constant. Next, we need to multiply x with 2x squared minus x cubed, and we will get 3 over 4 integral from 0 to 2 2x cubed minus x to the power of 4 dx. Finally, integrate 2x cubed minus x to the power of 4, and we will get 8 minus 32 over 5, and we need to multiply it with a constant, which is 3 over 4, and the final result will be 6 over 5, and this is the mean. That's all for me. Thank you for listening.
Next, let's move to the next question. The question is find the variance x, variance 0.5x, and variance 5 plus 2x. The first thing is we need to know the formula of variance x. The formula of variance x is ex squared minus mean squared. For the previous question, we know that mean is 6 over 5 and k is 3 over 4. So we need to find the value of ex squared. For the formula, ex squared equal to the integral from negative infinity to the positive infinity of x squared times fx dx. For the formula, we put the value, and the answer of ex squared is 8 over 5. Before we move to the question, do you remember about properties of variance? No? Okay, let me tell you. There are three properties of variance, which is variance A equal to 0, variance AS equal to A squared times variance S. Next, variance AS plus minus B equal to A squared times variance S. So, let's look for the first question, which is variance S. From the formula, variance S equal to ES squared minus mean squared. So, we put the values of the ES squared and minus squared, which is 8/5 minus 6/5 squared. The answer of the variance S is 4/25. So, next, we need to find variance 0.5s. So, the question is, we use the properties of variance, which is variance AS equal to A squared variance S. 0.5 is A, so we write as 0.5 squared times variance S equal to 0.5 squared times 4/25, and the answer for the variance 0.5s equal to 1/25. The last question is variance 5 plus 2s. This question is same with the properties of variance. Variance AS plus B equal to A squared variance S. So, as we know that variance A equal to 0 plus 2 squared variance S. And we calculate that the final answer for the variance 5 plus 2s is 16/25. Okay, that's all from that question. We have answered all of the questions. Thank you.
In this project, we reinforced our knowledge of continuous random variables. In conclusion, continuous random variables can be measured. We use knowledge of probability distributions and the formula associated to find the mean, variance, and standard deviation for each probability distribution. We also use the formulas to find the maximum and minimum usual value. This project also required an understanding of the criteria of a binomial probability distributions. In order to find mean, variance, and standard deviation, you need the number of trials along with the probability of success and failure. The last concept that we used was the binomial probability formula. This project helped us better understand the connection between the binomial probability formula and the formula of combination. I think that's all from us. Thank you.